Hey everyone, welcome back. In this video, I'll be talking about the famous n queens problem. The description of the problem is simple. Place n queens on an n cross n board such that no two queens attack each other. Let us take an example here on a 4 cross 4 board. Here, queen 1 cannot attack any other queen. Queen 2 cannot attack any other queen. Queen 3 cannot attack any other queen, and also queen 4 cannot attack any other queen. Now, this is one of the solutions to this problem. So we have to find out all possible solutions to this problem. So how do we solve this? So for two queens not to attack each other, let us identify the conditions. The conditions are queens cannot be in the same row, queens cannot be in the same column, and queens cannot be in the same diagonal. So we meet these conditions by placing each queen in different rows. So that solves condition number 1. For condition number 2 and 3, we try to place the second and the subsequent queens in every column from 0 to 3. So here we check if there is a previous queen in the same column or the same diagonal as the current queen. If this is true, then we try to place the current queen in another column. If we don't find a column in the current row where the queen is not safe, then we backtrack. Now, how do you check if two queens are in the same diagonal? From high school math, we know that equation of a line is y2 minus y1 is equal to m into x2 minus x1, where m is the slope of a line. Now here, in case of a square, we know that a diagonal inclines to each sides at an angle of 45 degrees. So slope m will be plus 1 or minus 1 depending on the orientation. So therefore for a diagonal line, the magnitude y2 minus y1 should be equal to x2 minus x1. So let's try to apply this formula for these 2 points here. Queen 1 is at 0, 1 and queen 2 is at 1, 0. Now y2 minus y1 is 0 minus 1 and the magnitude is 1. Similarly, x2 minus x1 is 1 minus 0 and the magnitude is 1. So that's why they are in the same diagonal and they can attack each other. Now to program this, let us try to use a list. The index of the list gives the row number and the values in the list gives the column number. So queen 1 will always be placed in row 0, queen 2 in row 1, queen 3 in row 2, and queen 4 in row 3. Now with this background, let us try to visualize this. So we'll try to place queen 1 in row 0 and column 0. This placement will be successful because there is no other queen to attack queen 1. Now let's try to place queen 2. So whenever we are trying to place a new queen, we are moving to another level in the recursion tree. So here we are trying to place queen 2 in row 1, column 0. So is this queen safe at this position? No, because they are in the same column. So 0 and 0. So we'll try to move to the next column. So is the queen safe at this position? So let's check that. Here queen 2 is at 1, 1 and queen 1 is at 0, 0. Now the difference is 1, magnitude difference between the y coordinates. Similarly, magnitude difference between the x coordinates is also 1. So they are in the same diagonal, so the queen is not safe. So we'll try to move to the next column. So here is the queen safe? Yes. So we'll try to move to the next queen and hence we'll move down the recursion tree. Now we'll try to place the third queen in row 2, column 0. Is the queen safe at this position? No. So we'll move to the next column. So is the queen safe at this position? Again, we can check it using the formula. So queen 3 is in the same diagonal as queen 2. So we'll try to move to the next column. So is the queen safe here? Again, no. So we'll go to the next column. Is the queen safe here? Again, no. So we have explored all columns for queen 3 and we have failed. So we backtrack, that is we go back up in the recursion tree. Now we'll explore the other columns for queen 2. So we'll place the second queen in row 1, column 3. Is the queen safe here? Yes. Now we'll try to place the third queen. So we are moving to another level in the recursion tree. So here third queen is placed in row 2, column 0. Is the queen safe at this position? No. So we'll check the next column. So is the queen safe at this position? Yes. And now we'll try to place the fourth queen. So we'll move to the next level in the recursion tree. So here we'll try to place queen 4 in row 3, column 0. So is the queen safe here? No. So we'll check the next column. Is the queen safe here? Again, no. So we'll check the next column. Is the queen safe here? No. So we'll check the last column. Is the queen safe here? No. So we have checked all columns for queen 4 and we have failed. So we move back up in the recursion tree. Now let us try to explore the other columns for queen 3. So we'll place queen 3 in row 2, column 2. Is the queen safe at this position? No, because it is under diagonal attack from queen 2. So we'll place queen 3 in row 2, column 3. Is queen safe at this position? No, because it's in the same column as queen 2. So here we have explored all columns for queen 3. So we go back up in the recursion tree. Now for queen 2 also we have explored all columns and we have failed. So we go back up in the recursion tree. Now let's try to place queen 1 in the next column. So we'll place queen 1 in row 0, column 1. So queen 1 will be safe because there is no other queen to attack it. Now let's try to place queen 2. So we'll place queen 2 in row 1, column 0. So because we are placing a new queen, so we again move to the new level in the recursion tree. So here, is the queen safe at this position? No, because it's in the same diagonal as queen 1. So we'll place queen 2 in row 1, column 1. Is the queen safe at this position? No. So we'll explore the next column. Is the queen safe at this position? No. And we'll move to the next column. Is the queen safe in row 1, column 3? Yes, because it's not in the same row, same column, or same diagonal as queen 1. So this is a safe position for queen 2. So now let's try to place queen 3. So we will move to the next level. So is the queen safe at this position? So it's not in the same column as queen 1 or queen 2. It's not in the same diagonal as queen 1 or queen 2. So this is a safe position. Now we'll place queen 4 in row 3, column 0. So we are again moving to the new level. Is the queen safe at this position? No. So we'll check the next column. So we'll place queen 4 in row 3, column 1. Is the queen safe at this position? No, because it's in the same column as queen 1. Now we'll place queen 4 in row 3, column 2. So here queen 4 is not in the same column as queen 1, 2 or 3. It's not in the same diagonal as queen 1, 2 or 3. So the queen is safe at this position. Now we have placed all 4 queens correctly and this gives us one of the solutions for this problem. This is the same solution that we saw at the beginning of the slides. Now when we try to place queen 1 in the next column, so we get this another solution by doing the same backtracking technique. So now with this understanding, let us try to code. Here the output is represented as a list of strings. So when we represented the queen, we used a list of integers. So we'll use a list of integer and then we will finally convert that list of integer to this list of string. So let's try to code now. The output is a list of string output. we'll have a recursive method called 𝗂𝗏𝗏𝗁𝗏. We'll pass in the number of rows or columns. We will pass in the output. We'll have a new array list. We'll send a new array list. This is the list of strings, list of integers that will have the solution, and the current row, which is 0. So we'll return the output. So this method will do the work for us. Now private, the 𝗂𝗏𝗏𝗁𝗏 does not return anything, so we'll have void int n list of string output. We'll have a list of integer. This is the way we represent it. We'll name it solution and int row. Now, if my current row, if we have found a solution, we will go to the next level, that is 4. Now, if n is equal to 4, that means we have found a solution. So if my row is equal to n, so we have found the solution. We will add it output.add solution. But we want to convert this solution to a list of string, so we will have a helper method that will convert the solution. We'll also pass an n. This will convert the solution that we have to a list of string, and we will return. So now we want to check for every column. So we want to check for every column in this board. So for int we'll place the queen in every column. So solution.add column. Now we'll check if the queen was safe in that particular column. So if is queen safe in this column. So for this method we'll pass in the current row, the current column, and also the solution. If this is true, then we want to go to the next level. So we will call this same function again, and we will pass an n output solution, and we will go to the next row. So once we are done with this, once we are done with one level, we want to go back to the previous row and then explore all other columns for the previous row or the previous queen. So we'll do this solution dot remove current queen. So it's solution dot size -1. So this should do it. Now we'll write the helper method, or this 𝗂𝗏𝗏𝗁𝗏 method first. It's a boolean. So this row is my current queen row, so I'll name it current queen row, and this column is the current queen column, and this is a list of integer solution. Now we want to iterate through every row and then check if the queen is safe. So for int previous queen row is equal to 0. Previous queen row is less than current queen row, previous queen plus plus. Let's try to get the column of the previous queen. So in previous queen column is equal to solution dot get of previous queen row. So this is the mapping. The solution will have the mapping between the row and the column. Now we'll check if my current queen column is same as previous queen column, or the or we want to check if they are in the same diagonal. That is, we want to check the y coordinates and the x coordinates. So my math.abs of previous queen, or we could do this way, current queen column minus previous queen column. So that is y2 minus y1. This is equal to my current queen row minus previous queen row. So this is x2 minus x1. If if either of these two is true, that means the queen is not safe. So we'll return false. If we checked all rows, that means we have found that the queen is safe. Return true. Now we will create this helper method. So private, the helper method will return a list of string helper. We'll pass in a list of integer solution int n. Now we'll create a list of string list as the output. Now we want to check for every row and every column. So for int row is equal to 0 is less than n, and we'll create a string builder for every row. Now for every column, so we'll have to check if my current column is equal to, so this solution will have the mapping between the row and the column. So solution.get of row, if this is equal to the current column, that means that we have the queen in that column. So we'll append the queen. Else we'll append the dot. We'll add this to the str list sp.toString. At the end of it, we'll return this str list. I'll run this code. So it seems to work fine. I'll submit the solution. So let's check that here. So it seems to work perfectly. So thank you very much for watching this video. If you enjoyed it, please hit the like button and also do subscribe and share it as well, please. Thank you.